In this video, we present the technical details related to the Experience project. Experience focused on performing a detailed performance analysis of the NAV technologies provided by the SoftFIRE infrastructure to support a wide range of augmented reality scenarios facilitated by 5G networks. In particular, a series of stress testing scenarios were performed over the testbed of University of Surrey in a 2-day experimental session to assess the network performance under different requirements imposed by AR applications in terms of capacity, latency, and uniform experience. The first scenario was based on the cultural heritage and arts domains, providing the user with 3D content and high-resolution videos about historic monuments. The application was built using the Unity 3D environment and Vuforia framework for the optical detection of target images. This scenario investigated the capability of AR applications to take advantage of the storage provision by a cloud facility via a 5G network. In order to set up this scenario, we created an experiment that installs a server in a dedicated VNF that serves video content by using the installed scripts. The C-jar file that we prepared could be uploaded in the experiment manager through the reserve resource facility. As soon as the required resources were reserved, we were able to deploy our VNF in the SoftFIRE infrastructure. This process could take some minutes. Here, you can see that the VNF could progressively be installed in the cloud. At some point, we were also able to connect to the hosting machine by using the floating IP provided by the platform. Eventually, the VNF would become active and then we would be able to run our applications and perform the measurements we needed. In order for the mobile applications to connect to the video server, the user could just type in the IP address of the hosting machine and then he could have access to the provided multimedia content. The experiments and the measurements were performed in the University of Surrey, and in order to connect with the cellular network, we installed SIM cards that allowed us to connect with the provided FEM2CEL. The second scenario was based on the vocational training domain. The scenario took advantage of the recent AR framework capabilities in order to detect surfaces in the environment and project audio and other multimedia content to the application layer via the high bandwidth cellular network. Here is how this application works.
Foam extinguishers are painted signal red with a cream panel. Foam fire extinguishers are suitable for use on Class A fires like paper and wood, and Class B fires involving flammable liquids. To use a foam extinguisher, pull the safety tag to break the seal. Pull out the safety pin. Hold the handle in the discharge hose. Test the extinguisher to check if it works.
How to use a fire extinguisher. Accidents happen. Be prepared to fight your own fire by learning how to use a fire extinguisher. You will need courage, calm, and a fire extinguisher. Step 1. Know how fire extinguishers are classified. Class A extinguishers are for common combustibles like paper or wood. Class B are for flammable liquids, and Class C are for electrical fires. The Red Cross
Again, for this scenario, we created an experiment that installs a server in a dedicated VNF that streams audio content by developing appropriate install scripts that set up our environment. The process for reserving the necessary resources and deploying the audio server through the experiment manager is similar to first scenario. In this part of the video, you can see an example of the deployment of this experiment in the testbed. Again, in order for the AR application to connect to the audio server, the user could just type in the IP address of the hosting machine. The third experiment exploited the storage capacity of the SoftFIRE cloud in order to transfer images and textures used to render the planets of our solar system. The application was implemented by using the ARKit framework of Apple for inspecting flat surfaces. The user can insert the planets of our solar system in the real-world surfaces using the high-quality textures retrieved by the network. The fourth and last scenario was based on the domain of education and in particular the field of kids learning. The application was built using the Unity 3D environment and Vuforia framework. The application rendered 3D quizzes to the user where the questions were randomly retrieved in real time from a pool of available questions in the database stored in the backend. This scenario required a low latency network and assessed cases in which AR applications demand fast transmission of small-sized messages in order to provide high quality of service. For both these scenarios, dedicated VNFs were created and the process to deploy them is similar to the first and second scenario. As we mentioned before, the stress tests that we performed were executed in the University of Surrey. More specifically, we evaluated the quality of service and uniform experience that the infrastructure could provide to our applications by measuring the latency, the bandwidth, and the stability of the network. In order to carry out this task, we used several network tools that helped us gain insights regarding the efficiency of the testbed. We ran several tests by running single or multiple instances of the application in parallel in order to have a clear and complete view of the performance of our applications. In terms of KPIs, our final results that are also included in the delivered technical report are the following.